Next, even though exploratory vector analysis, sometimes called EFA, this is to test the underlying structure among the variables, right? Underlying structure among the variables. Sometimes we say testing dimensionality, whether they're coming from one or more than one dimension, right? So things to do, administer question, same target population, sample size minimum, generally minimum 100. If no changes are made in the pilot test, the cases can be considered. We did pilot test before. Supposing no changes in the questionnaire after the pilot test, example, 4 remain 4, everything, no changes. So this sample size of 30 can be added to the exploratory. We bring another 70. If changes are made, some items were dropped, therefore become 3 here, then start all over again, back to 100 again, right? So that's a general way of doing it. Now, in this case, you're going to have abstraction, use principal axis factoring, not principal component, which we have towards. If more than one factor extracted, then we do rotation, oblique method, not varimax, right? So these are things we're going to do and how to apply it. All right, look at these two structures now. The F's are called the latent variables. Example, satisfaction. That's a concept, and define what is satisfaction, and we devise these items to measure this. Now here, which is dependent, which is independent variable? F1 is what? Dependent or independent?
Independent.
Independent. Why? The arrows are going this way, right? We done regression. The arrow leads. We call it independent. Sometimes call it exogenous. Exogenous. And where the arrow ends, there's a dependent variable, also known as endogenous. Exo, arrow exits, endo, arrow ends. So here, this is what, let's say, example, this satisfaction. Where is satisfaction residing? Where is the satisfaction residing in the customer? Where? Jeffrey, where the satisfaction resides?
Sorry?
In the head, right?
Yeah.
Ah,
Sir,
yeah.
my internet. Sir, I'm still doing it because for network the SPS is very slow. So I will send it later.
No need to
Okay.
send. That's not for sending, right? For you to practice, okay? Don't have to send that.
Oh, okay, okay.
All right.
Okay.
So now, example, we
Okay.
measure customer satisfaction. That's residing. We assume this is residing in the head. How to bring it out? We devise a question. Let's say I give 5 questions. Let's say on a Likert scale of 1 to 5, and ask him to answer the question. The guy, how the guy answers the questions depends on what the head is telling, right? What the hand marks depends on what's inside the head, right?
Yes.
Yes. Supposing 1 is strongly disagree, 5 is strongly agree. The guy marks 4, 5, 4, 5, 4, 5. That means strongly, highly satisfied. The guy marks 1, 2, 1, 2, 1, 2. That means the guy is not satisfied. So what he marks depends on what's in the head. So these particular indicators are called reflective indicators, reflecting what's inside the head. On the other side, which is dependent variable? Which is the dependent variable?
F2.
F2 is dependent variable. So these indicators are formative indicators. Whatever comes here formates for this particular construct. Example, let's say this is BMI. This is triglyceride, waist circumference, BSA, whatever it is. When these values are high, we expect a big body structure. I say over phone, asking what's a BMI, he say BMI 32. What's the waist size? Waist size is 50. What's the tricep, bicep, all that, all are very high. Then imagine the person is very, very fat. But by working on it now, BMI will go down, all the values will go down, then we have a smaller body. So it's called formative indicators. We measure this, based on that, we form this. Now this is called principal component analysis. So most of the studies using questionnaire, they are not formative, they are reflective in nature. So give a questionnaire, so what do you say about this? What do you say about this? These are reflections. Example just now, we talk about remuneration. What do you think about this, and this? One guy marks at a 1 to 5, 4, 5, 5, 4. Then it's perceived positively remuneration. Another guy marks 1, 2, 1, 2. That means the guy's perception is very low, right? So this question, the response they give, the answers they give, is a reflection of what inside the head. So it's called reflective indicators, all this now. So most of the time, we deal with reflective indicators, right? So this class, we're going to talk about only this. Of course, this is a major area, plays a major role in statistical analysis. So we're going to talk about this, right? Concept. We design a questionnaire. That's how we saw the pilot study, how good these items are in pilot test. We go more detail now. We're going to talk about whether how these variables are coming from same construct or not. So what do you look for? 5 things. Same like just now. This number 2, number 1, same as the pilot study. Number 3, we're going to talk about one more statistics. It's called KMO or Kaiser-Meyer or Kin. More than 0.7 is considered good. Next, how many factors extracted? It can be 1, can be more than 1, we don't know. Pilot study does not tell that. And how much variance extracted. This must be more than, but some researchers say more than 60%. More than 60%. But for me, anything more than 50% should be substantial. Factor loadings. Factor loading is nothing but regression coefficients. Must be more than 0.7 or more than 0.5. Again, all this, there's no calculation. You're going to click some buttons and just going to observe this. Right.
Professor,
Yeah.
do we need to refer to the Bartlett test?
Either
value?
one will do. Kaiser-Meyer will do. Right?
Oh,
You put
KMO or
Bartlett as
Bartlett.
well, it's okay. Right?
I just choose either one, right?
You can put both, doesn't matter.
Okay,
But we are looking more into this.
okay,
Right?
okay.
Bartlett's more on a sample size.
Mm.
All right. So again, we choose this. That's my procedure. Analyze dimension reduction factor. So this will pop out. The first construct, remuneration. So bring remuneration inside, same like a pilot study. And then under descriptive, click descriptive, go into this. Coefficients, KMO. These two are important. I can ask for univariate statistics as well. Most importantly, correlation and KMO. Continue. Then come to extraction. Extraction default is principal axis. Principal axis refers to this component, which is formative indicator. Ours is not formative, ours is reflective. So most of the time it shows principal axis or other methods. So other methods there, maximum likelihood, other things. For this class, we're going to use principal axis. Don't use principal component. All right, continue. That's all. So bring the data in. Statistics, I want coefficients of KMO. Extraction, change to principal axis factoring. That's all. the results. Condition number 1, we can see all these standard deviations are more than 0. Condition number 2, look at the highest values, each column. They are between 0.3 and 0.9. K more Bartlett. So Kaiser-Meyer more than 0.7. That's good. The Bartlett is less than p-value less than 0.05. Right? Variance explained. Now look at this table. How to interpret this table? How many items are there? How many
4,
questions? Yeah,
4 items.
4 items. So this column refers to a number of items. There are 5 items. There is 1, 2, 3, 4, 5. So this tells you initial analysis. Initially, there were 4 rows, 4 items. This is after extraction. How many rows are there? How many rows now? Here, how many rows?
4.
Yeah. Okay. How many rows here?
4.
2 rows. How many rows?
4.
4 rows. This indicates there are 4 items. How many rows on this side?
1.
1. That means the 4 items can go into one factor. 4 items can go to one factor. Analogy. 4 people went for holiday. How many rooms they took up? How many rooms? How many rows?
1.
1 row. Is analogous to 4 people went for holiday. They took up 1 room. What does it mean? What does it mean? They must belong to the same family, right?
Yes.
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 They belong to one family. 4 people went for holiday. They took up 1 room. So this is analogous to, it must be one family. That's basically what you're asking. These 4 items, did they belong to one construct? Now, variation explained. How much variation explained? 60%. 60%. Is it more than what we require? The minimum you want? Okay. The minimum looking for at least 50%. Now we have 60%. That's good. Putting the 4 into one basket out of 100% explains 60%. How to get this value? This is your slopes, factor matrix, right? That means what's the value of this slope, everything. We know it's regression. Square these values, and average them. That's a value. 0.8 square, all these square, and then add them up. That's a value. So the 5 conditions we have: dissatisfied, dissatisfied, dissatisfied. 1 out of 4, they become one factor. 60% is good. And what are the individual vector matrix? Now, which is the weakest here? This must be, what's the minimum value? Must be at least 0.7, right? Factor loading. This must be at least 0.7. What's the minimum value here? 0.57. Is it okay?
Yes.
But must be at least 0.5 and above. So even though slightly low, still more than 0.5, we keep it. If this value is 0.27, too small, we drop it and do one more time analysis. So this is what I look for in factor analysis. Right? Okay, let's do this. Hold on. Okay, reporting it. So what do you report? These are descriptive statistics. Came from this table. From there, you can see that the mean scores upon 1, 2, 3, 4, 5. These values are mostly below 3. That means they're not happy generally. All these correlation values are obtained from this table. That goes in here. They will explain this. The assignment will be something similar to this. As shown in table X, maximum correlation values for the items are between 0.3 and 0.9. Hence, items are correlated adequately in the construct. In exploratory vector analysis, KMO value, where KMO value was more than 0.7 is considered very good. In the analysis, how many factors are extracted? In the analysis, we have one factor extracted that explains 60% of the variation. Right. The minimum factor loading. So minimum factor loading is 0.570. So by this write-up, we are telling that these 4 items here, 4 items coming from a single construct. Again, this is not validation yet. We complete pilot study and this EFA, we have completed what we call psychometric properties. Psychometric properties. This is a bare minimum you must have in your research. So this will be mostly in chapter 4, we do this. Pilot study will be chapter 3. Pilot study getting ready for data collection, right? Pilot study. So before that, your constructs, before your model, this is my objective. These are my concepts. What are the definitions? Again, how to measure this. The measurement must be good. We'll talk about this too. We got some questions from the literature, citing the sources, and then content validity, pass to a expert panel, whether they approve or they reduce some items, add some items. Next, pilot study. We take the questionnaire to your population, target population, collect data, we look for this. Because you want main last one here, but these two also equally important. Do the analysis. So what do you look for? And fill up this table. So this will be chapter 3, getting ready for data collection. Before that, get testing the instrument, is it okay? After whatever correction done, okay, fine. So now we're going to collect more data. Even the purpose is this, some may conclude this end of study based on exploratory vector analysis. So we do this. That's what I look for, because dealing with number 1. So what do you look for here? How to do the analysis. These are the outputs and how to report this. Right? So look at the last one here. Right. From here onwards, everything's okay, good. They belong to one construct. Okay, reasonable. Take the mean of the 4 items and use in the first analysis. Take the mean of the 4 items as a score on remuneration, because most of the thing we are looking for is fulfilled. That means average of the responses is a good indicator of how they felt about remuneration. Okay, let's do it. The data is data for the data. Which file is that?
Data from pilot pilot study.
Pilot study done, right? What's the other one? Next one.
Factor analysis.
Factor analysis. Data for factor analysis. Okay, data for factor analysis. Yeah. Okay, data for factor analysis. Right. So these are same items as we approved earlier. Okay, let me remove this first. Delete this first. All right. So let's start. Follow the instruction. So analyze, dimension reduction, factor. So bring the items. Next, click descriptors. This univariate to find the mean and standard deviation, click coefficient and KMO. Continue. Extraction. Change this to principal axis. You can use maximum likelihood other thing, but most of the time we do this. Continue. That's all. Click OK. Look at the results. In this table, we have correlations. The maximum values are between 0.3 and 0.9. KMO is more than 0.7. Out of 4 become 1, explaining about 60% of variation. And last one, this is my vector loadings, like the regression coefficients. That's its minimum value. So pick it up and report it. Okay, I'll show you how this is done. Okay, results from here, results from factor analysis. Which construct is this? Which construct? Class, which construct? This is a remuneration construct. There are 4 items. Statistics are shown here. All right. Okay, this table, for the output. Just a minute. Okay. The output. Okay, it's output. All right. So I want these 2 tables. Okay. If you copy and paste like that, I'll give you 0. So you modify the table according to like what you have. First APS style can be, you can take out the columns. At least minimum, I want this. And besides that, with this, okay, must be same font as font size and font as font here as this one here. So yours is 12. Right. Decimals, 2 decimals enough. Okay, this can be 3 decimals. Insert a row above. Like this. So this is inter-item correlation. Like this. Descriptive statistics. And these are collapses items. Right. So table should look like this. Based on that, you can do the write-up. So table X. Okay, now you're doing for enumeration. For this, there are 4 items, the construct. If you want, you can add this, each item. The scale of 1 to 5. To the statement, so that you can interpret what this means. So 1 to 5, 5 indicate some of the midpoint, all are below midpoint. So generally they're not very high. All right. Then interpret what's the table. and also what the other output. So don't have to copy and paste all the tables and put inside there. You like the table so much, put the appendix. So that's information we need. Right? So you're telling what you're doing. You're doing vector analysis on what experimentation and how they measure, how many items, how they measure, and what are the results it's showing. I'm showing the descriptive, right? On the descriptive and also the correlation, and show the table. So you have and explain what it means. The last part, the mean of the 4 items were computed and used for the analysis. Vector analysis is not the end, it's only means for further analysis. Right. Let's continue. You complete afterwards. You're going to compute the means. So since we found that the 4 items are good indicators, transform, compute. Let me give a name. This is which variable, which data set. Okay, transform, compute. The variable name, let's give remuneration. Over here, mean, the function's mean, bracket, from 1, you want to put comma also can, otherwise 2 space, 2 space, last one. From 1, give a space between, to that. Click OK. So in your data, look at the last column. Let me bring nearer to the items in the construct. Okay. So look at the scores. 4, 4, 4, 4, average is 4. So 4, all this value means they're more agreeing. Look at this value here, case number 13, right? So this captures that this guy, whatever case number here, is not very satisfied. Whereas here you can see this guy is satisfied. So once you've done this, we don't need these items anymore. We tested, all are okay, and summarized. That's the value we're going to take it up from here. Right? Again, what's our objective? Our objective is this: factors, intention relief, and factors associated with the intention relief. Right? You do the same thing for the other 4 variables. Let me do it fast. Analysis. Next is the CDs. Right, descriptive, you have this. Extraction, you have this. Okay, later fill up the table. Now, SD is okay. Highest value looks okay. KMO looks okay. 4 become 1. 1 factors extracted, but your AVE is rather low. But based on your vector loadings, all are more than 0.7. But I like this to be high, but that's all I can have. So I report as it is, right? You already saw this earlier in the pilot test. There was a weakness in this construct. So I compute. This is for, what is the variable for? Yeah, what is CD? Challenging, job challenge. Are you all with me?
Yes.
Right, job challenge. So again, all
So
the four, yeah.
show again how to get the compute variable. Which part?
Go to analyze, transform.
Thank you.
Good. Right. So now this is job challenge. Let's put job. So now the mean from, so this construct is not as good as the previous one. Right. Click OK. I'll continue the next one. JC. Browse through. Okay. Looks okay. All right. Okay. One factor. So much. Factor loading. Okay. Now come to factor loading. Is it satisfied? Is our factor loading satisfactory?
No,
Why not?
GC1 is less than 0.5.
0.5. Now round it up, it's already 0.5, right? Isn't it? Isn't it?
It's almost 0.5.
Right. But strictly you want to follow the rule, then what do you do? Redo and drop that. And see whether much improvement here. Is it much different? From 50% has gone up to 59%, right?
Yes.
Is it good?
Yes.
Right. Now, what do you report here? Word file. Okay, what do you report here? Let me do that here. How this should be reported. Again, it's my table. So I take these values. Sorry, there are 4, right, initially. Go to the initial one. Okay. Next table. I'm just showing a variation. Right. So in this table, are all the conditions met? The first 2 conditions are met, correlation, everything?
Yes.
Until here, is it okay? Is it okay until here?
Yes.
Yes. Next, the KMO. Is KMO more than 0.7? Is KMO more than 0.7?
Yes.
770. Good. How many factors?
One factor.
One factor. Extracted and explained about 50%. 7%. The minimum factor loading was, so what's the minimum factor loading? 0.496. 6 for item JC1. JC1. Right? JC1, which is less than 0.5. And this item was dropped. So redo the analysis. With the item dropped, took it out. Okay, what changes now? All these don't have to mention, only this vector loading and this one here was dropped. After dropping, that's it. After dropping JC1, the AVE was how much? 59.5%. You can see that it's a huge improvement from 50.7 to 59, almost 10 points. That's very good. Now I can say the minimum vector loading was so what's the minimum vector loading? 0.714 or more than 0.7. Okay, that's the improvement. See, we didn't see this much in your final study. So now I can see really JC1 does not fit in well in this construct. Next, the mean of the 3 items now, not 4. The items were computed and saved in the further analysis. With this variation, that's how it may look. All right. So this is for which variable is it? Job. Which variable? Which construct? Which construct? We'll change it, okay, accordingly. Okay, that's one variation. Okay, now I'm going to find the mean of the 3 items only. Transform, compute, just not job challenge. See, what's the variable? JC? I can't remember. This job challenge. So just now it's not job challenge, it's career development earlier. Okay, this one is career development, this CD. Next is job challenge. Okay, job challenge. So that's going to mean of the 3 items only from JC2 to JC4. So here this JC1 is not here, it's been dropped. Right, that's saved. Last one, ITL. ITL. That's good. Came okay. 4 become 1, 61% is good. Minimum 6.5. Okay, not too bad. Go ahead. You want to drop it. It's not necessary. It's really more than 60%. So you can find the mean of these 4 items. Intentionally. Will be mean of these 4 items, ITL 1, 2, ITL 4. Click OK. Let's go back to our data. So we don't need all this anymore. Make your data file much simpler. All right. Remuneration. I think this was before this. Remuneration, career, job challenge, and intentionally. So it's called data reduction. Instead of 4 by 4, 16 items, now you concentrate only on 4. Jeffrey, what's my objective?
The objective is to know the association between the intention to live and the remuneration, challenges, career, and job satisfaction.
But before that, what's objective 1?
To determine factor associated with intention.
Oh, there are 2 things. That's number 2. Number 1, you want to assess the intention to live, right?
How many % of them are having?
What's the level of intention to live? Number 1. Number 2, what are factors associated? The 2 objectives, right?
Yes.
Okay, first objective. This is quantitative or qualitative? Quantitative or qualitative?
Quantity.
Quantity. So you describe. Analyze, descriptive. Now, you want to test normality, is fine. You want to test all these, are they normal? Also fine. So let's test normality of all the 4 items. Analyze, descriptive, explore. So go to the 4 variables. You are test whether normal, plots, test the normality. Sometimes people ask whether scores were normally distributed or not. Okay. Sample size 308. What are p-values? P-values,
Significance.
are they all less than 0.05?
Yes.
What does it mean?
They have a relationship. I mean, is associated with these.
No, test the normality. It means they are not normally distributed, right?
Yeah.
Right. Let's look at the plot. Any major outliers, extreme values, the box plots. We don't see any major outliers or extreme values. Right. So in this kind of situations now, already given the notes earlier, we look for sample size 300. We look for skewness and kurtosis. Skewness and kurtosis. As long as skewness less than 2, kurtosis less than 7, we can say the data is fairly normal. Same thing here. Same thing here. So data is fairly normal. To present this now, don't copy and paste this table. Now go to analyze. Do the frequency. Analyze descriptive frequency. Easier to summarize this. What I want in the analysis is statistics on the mean, standard deviation, skewness, kurtosis. From this, we can justify the data is fairly normal. Look at this. Get this a table I need. So I remove these 2. Decimals too many. So I make all 2 decimals. And I take out this skewness, standard error. Now what to present, okay? Rather have these variables in the column. How do you do that? Go to pivot, transpose. Right. I can see enumeration, what's the mean, standard deviation, skewness, kurtosis. So summary from vector analysis. After doing all that, for every construct, the summary from vector analysis. So descriptive summary. Sometimes I call it summative scores. Descriptive summary. Again, make sure you follow the same right formatting. So I can see that in this table, the skewness and kurtosis values as shown in, let's call it table Y. For all variables. Right. So after doing this, for each one of the construct, you summarize this. Right? So you can see intentional leave, is it generally high or low? Is it generally high or low? Hours 1, 2, 3, 4, 5.
In the middle.
In the middle, you want to know the confidence interval in your descriptive statistics. Okay, so intentional leave, when the confidence interval is between, what's confidence interval? 3 point, this value is right. Are they both interval more than 3?
Yes.
Yes. So how to write this? The 95% CI for intentional leave is, so what are the limits between these two values? Three 3.18, 3.38. So is it generally on the higher side? Is it generally on the higher side? Our scale 1, 2, 3, 4, 5, right?
Yes.
So this value is more than 3, right?
Yes.
So generally there is contention relief. So that's for objective number 1.
Prof, I want to ask, right, if
Yeah.
let's say the skewness is -3,
Hmm.
do we look at the negative?
Doesn't matter negative or positive, the absolute value only. Absolute
Okay.
value. Yeah?
Okay.
Absolute value. I can put here, we want to in absolute value. All right, is fine. So objective one, what are people thinking? Are they thinking of leaving? And 95% CI for intended leave within this and this. So what does it mean? We bring to discussion later. So what is the second one? Factors associated with intention to leave. What are factors? So now go back to data. What are factors associated with intentional leave? So you have these variables, and these variables also important. Are these variables also important? Class?
Yes.
Yes, these variables also important because intentional leave may also depend on monthly income, length of service, and other things, right?
Yes.
So what analysis will you do?
Multi-binary.
Multi-binary,
I mean the let me double check.
which is the dependent variable here? Which is the dependent variable?
So
Dependent,
let's use
yeah.
the general linear
Say again?
regression.
Now, which is the dependent variable?
Or which one it depends? Yeah, intention to leave.
The leave.
Yeah.
And on this side, we have combination of quantitative and qualitative, right?
Yeah.
Yes.
Multiple logistic regression.
Logistic for yes, no.
Multifactorial.
Logistic for this is binary. Now, I'm going to ask several questions. But I want to know this. What analysis? See, revising all the analysis done before.
Multiple linear regression.
Multiple linear regression. But I want to know only this. What analysis? These two only. What's analysis?
Dependent t-test.
Independent sample t-test. Want to do only these two. What analysis?
Multi.
We don't know. Find out how many levels. There are 3 levels, right?
Yes.
Yes.
I wanted only this.
Multivariant.
ANOVA.
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 We are revising all those we done earlier, okay? Gender, male, female, 2 levels versus intentional leave, right? So t-test. This intentional leave qualification, 3 levels. Therefore, 1 way ANOVA. This is if you're doing univariate analysis. Monthly income, 3 levels. What else?
ANOVA.
ANOVA. Length of service.
ANOVA.
ANOVA. I don't know why most of you others are free, are very, very quiet. So now what analysis? These two.
Linear regression.
Simple, linear regression. Why called simple? The one predictor, right?
Yes.
Simple linear. Now, how about this? Multiple linear. Now, what about all?
General linear regression.
General linear models, combination of quantity and quality. Better go revise your notes, okay? Quantity and quality. What's my objective? Factors associated with idea. Factors are some are quantitative, some qualitative. So method is general linear models. Right, this intentionally gender, qualification, income, length of service, they all are fixed factors, qualitative. These are quantitative. Go to model. Build model terms. Go back and check how you did GLM. Continue. What EM means, all the variables, write the mean and standard error, any difference. And then for these variables, we'll ask for parameter estimates for quantitative variables. That's all. So factors associated with intention relief, quantitative. It's not somebody say logistic regression. If this is binary, yes, no. Intention relief is not binary. So not this analysis. Regression analysis. Okay, this can go there. But the independent variables are combination of quantity and quality. So not this. So three major methods we studied. So gender, all these are qualitative. Go into this. These are quantitative. Go into covariate. Go to model. Build terms with one interaction. All inside here. So EM means to see what is the mean in the groups, how they differ. So these are EM means. Compare, so this is a post-hoc test. For quantitative variables, we want to know the regression coefficients as the slopes, parameter estimates. That's all. Okay. Now, which variables? Not gender, not all this, only these two, right? Right? Only these two. How do they work? Remuneration and career. Okay, these two. Can you describe how it works? Again, what's R square? R square is only 16%. How does it work? How does it work? Positive or negative?
Negative.
Higher the perceived remuneration, lower the intention to leave, right?
Yes.
Higher the perceived career development, the lower the intention to leave, right?
Yeah.
But what have we not done? For these variables, what must it test first?
Multicollinearity.
Multicollinearity must have been tested first, right? Because these three variables are quantitative variables, right? Again, step by step from here, what do you do? We've done this, do a summary, right? Summary statistics, produce this table. Where is it? Produce this table first. First table must be demography. First table must be demographics. You've done all these in your assignments and in your practice questions. So first is demography until here. So in your assignment, first table must be demographics. Next, we did a factor analysis, report the results from factor analysis, report from factor analysis, and then summary. Second step. Third step, we're going to factors associated Results from GLM. So we did a GLM just now. That's a GLM. This table. And go and check, okay, how you done earlier. We are done how to report this. So among the variables tested, all this. Right. So among the variable tested, we know that only these two are significant. The table, go and check how you reported the table, how you put in the table, right? So insert table, variable, mean plus or minus SE. And the p-value. So here, let's say gender. Male, female. So what values go in there? Look at the margin, estimated marginal means. So this for male, right? So these two values will go in that. Mean plus or minus will go inside here. P-value will come from this table. That's a p-value 0.158. So do the same thing for other qualitative variables. For quantitative variables, remuneration, career, and job challenge. We report the remuneration, so these values. So these are regression coefficients, negative 0.187, bracket, standard error 0.061. And the p-value for remuneration is 0.002. So we complete this table. So this will be results from general linear models. Right? Every table you number it as you go. All right. And then describe what is the association among the tested factors, variables, only these two are important and how they make a difference. I want this before exactly what you did for your exercise on reporting GLM. And finally, so that's your conclusion for objective 1 and objective 2. That's the first one. The 95 CI for this. So what does it mean? Factors associated, what are factors tested, and what are the factors significant, and what do they mean? So in this case, higher the remuneration, lower the intention leave. That means people are happy with what they get. They improve this, then most likely less people want to leave. Next one, your career, also significant. Higher the perceived career development, lower the intention leave. So people may want to leave, I think mainly due to these two. So how to retain them, you must look into the remuneration packages and also the career development for the workers. So that's a conclusion. Right? So draw a conclusion generally. So this is how I want your assignment 4 to be. Right? So first will be demographics. Respondents. So we're going to put a table here. I call it table 1. Of course, you must say something. Don't just put table 1. Say something. We have done this. Table 1 and describe. And describe. This is section 1. Section 2, results from factor analysis. So one by one enumeration. Go here with that. And one by one, all the factors.
Sorry, just to confirm, Prof. So we have to discuss all the variables here under factor analysis. So remunerations, then job challenges, one by one.
Ah, yeah, one by one.
Oh.
This for enumeration, right? Next for all the 4 constructs.
Okay.
And finally, this is summary.
Okay.
Right? And then we are talking about the factors associated with intentional leave. So that's a table. We don't need this table. So that's the table we presented. And then your conclusion. I want you to put a small introduction. Like HR manager wanted to know why, wanted to know the determinants of factors, determinants of intention to leave. Before that, HR manager was very concerned was, example, not happy, observed a large turnover in a factory, in this company. He wanted to know determinants of the intention leave among the workers. He conducted a study among his factory workers. You can see like a new, because came new to the new HRM, observe a large turnover in his company. She wanted to know determinants ITL among workers. She conducted a study. In the study, how many? The study, let's say about 200 respondents participated. Write something, okay? Now demographic, table 1. Factor analysis, this will be table 2. 3, 4, until whatever variables. And this whatever table, descriptive, and the results from GLM, and conclusion. Are we clear?
Prof, for the demographic, we say the demographic we collect is like example gender or monthly income, is it? That's
No,
all.
correct. No, from this study here, demographic in this study. In this study, these are demographics, right?
Yeah,
In my data set, only this demographic, right?
yeah.
So go here and put a table for
Okay.
demography, right?
Yeah. Okay.
Right. A table for demography. Last time we did. That's a part of the demography.
Okay. Then we just like describe a male or female with more.
Yeah, that's all. You've done this before, right?
Yeah.
Right. And percentage. So
Okay.
gender, how many male? 184, 59.7%. Right. You tell us who your respondents were. Right?
Yeah.
First table. Describe this briefly. You can see male and female. Are there more males and females in the study?
Yes.
Yes. Qualification, majority are degree. So don't have to say 100% degree, 100% diploma, master, no need. So most of the respondents, 59% are males, 60.7% degree, monthly income, 47.7% have the income at this level, and length of service, are they almost similar? Are they almost similar?
Yes.
Right. Length of service among the respondents are quite similar, less than 1 year, 1 to 2 years, and more than 3 years. Brief. Next, we go into this. So now you're telling what you're measuring, how many items there, how are they measured, what do they mean, right? So you're telling this, based on this, I can see whether means are they more than 3, less than 3, roughly we know whether they're happy or not happy, and the correlations, right? And the rest, so write up and saved. What is saved? Describe. So take it up to the analysis together with the demography and see how they make a difference. Questions?
Professor,
Yeah.
I'm not quite sure. Do we have to do this 0.25 level univariance first among
No,
the
in this
variable?
case, no. In this case, no. I just give you one.
Okay.
Only one time analysis, okay?
Okay.
All right. So your assignment is going to be similar to this. By tomorrow, I'll give you the assignment. Forget about whatever mentioned by assignment earlier, the email or whatever. Tomorrow, I'll give the assignment. Are we clear? I give the data set and who did the research, what was the objective, why the person did the research. I didn't say what's the objective was, but you're supposed to write the objective 1, objective 2. So the final analysis, whether it's a GLM or logistic regression, so you produce all the table. Are we clear?
So before we do the JM, we need to test the MC problem, right?
Yeah, multicollinearity problem. Yeah, forgot about that. Multicollinearity problem before doing the GLM. So these 4 variables. These variables, okay, right? Only this variable, predictor variables. And just throw something there. Right. Is there a major problem?
No.
Right. So where you report this? Report under this. Major problem of MC among. Put the variable enumeration here and job challenge. Don't include this as a dependent variable. That's complete. For a master's level, it's only your chapter 4. For a master's level, what I've done so far is already chapter 4. Any other questions? Any other questions?
Prof, do you mind to share this document with us?
This document?
Yeah, this Microsoft Word.
Okay. So
Yes.
now you're going to complete the whole thing now and send to me. You're going to complete the whole thing. Huh? Who is that? Hello? All right.
Yes, sorry, Prof.
Somebody asking something.
I think I have requested to have this copy of the
Okay.
document.
I'm going to send it now, okay?
Okay.
I'll send through email.
Thank you, Prof.
All right. So table 1, what do you need? And you're going to do it and send to me first. And all this discusses now. Summary and results from GLM and conclusion. Okay. Let me send through email or
Email.
email.
Yeah.
Okay, template for assignment. I can't say assignment, okay? No, can't say this. Factors associated with intentionally. Okay, that's all for class. Any other questions?
When is the due date for the next assignment?
Okay, due date will be next Tuesday, 7 o'clock p.m., 7 p.m. I'll put all this in the email, okay? As if it's the last class.
Thank you, Prof, for this semester.
All right.
Thank you so much.
Thank you, Prof.
All right.
Thank you, Professor.
Thank you, Prof.
Thanks, Prof.
All
That's
right.
cool.